Hi everyone. In this video I'm going to discuss vector scaling, which is basically taking one vector and multiplying it by a floating point number to scale its magnitude. Of course, if you multiply it by a number greater than 1, you're going to increase the size. You multiply it by a negative number or a fraction, you're going to shrink the size of a vector. Of course, you can also multiply it by negative numbers, which go in the opposite direction. As I indicated in the vector negation video, if you take a vector and multiply it by -1, it ends up flipping the vector to point in the opposite direction, 180 degrees away from itself. So here, you can't really see it, but we have a blue vector here, which is at 3, 3, okay? And I'm multiplying it by 2 to scale it up by 2. If I multiply the vector, you just multiply the x component times the scalar, and then multiply the y component by the scalar, and those become your x and y for the new vector. And as you can see, that created a green vector here, which is 6, 6. So it's double the magnitude of the other vector. And pretty much just like we multiply, we can also divide, okay? And divide, of course, we'll do the same thing, except you're dividing each component by a value, by the divisor, instead of multiplying by a scalar. All right. So that too can also be used to change the magnitude. Now, vector scaling or multiplication, of course, is commutative. You could do 8 times 2 is the same thing as 2 times a. It doesn't matter in the order in which you do it. So basically, that's it. The vector scaling that could be used, for example, let's say you had the blue one was a velocity vector, and you wanted to double the velocity of something. You could multiply it by 2, would double it. You could cut the velocity in half by multiplying it by 0.5, which would have taken the blue vector and cut it down by half. So thanks again. If you like my videos, please like and subscribe and pass it around. And thank you again. Have a great day. Bye.